string data structure. String is basically a set of characters, or it is an array or a set of characters. String is basically any kind of word that you represent in an English language. So string type is stored in the heap because we may not know its size at the compile time. Okay. And how to create a string? This is how we create a string. That is, let x equal to string from hello world. So what happens is we create a string from hello world, and hello world by default is an str, and what we are creating here is a string data type. So there are actually two string data types in Rust, but right now I want you to learn, okay, this is the string. And basically what happens is, um, here we have a string type. So we do have two different types, and the first one is the string, that is the large one that you can see, let x equal to the string. And then we have another string, that is the str. Okay, the str is by default a literal, can be described as an str. It is actually a pointer representing or pointing to a particular string. Okay, so these strings can be mutated, whereas the string literals can be as their pointers. Okay, so guys, I want you to pay as much attention as possible because we are going to discuss some of the major topics in Rust. Okay, so first, I'm going to start a new program, and that should be begin with an fn main function. Okay, and then we are going to create a string. So let x, let's name it. Okay, let s equal to string from hello world. Okay, so now we have created a string with the content hello world. Okay, now if you want, you can print it using the println function, that the string is s. Okay, you can do it, but this is not the interesting part. I wanted to show something interesting. So let new str is equal to s. Okay, now let new str is equal to s. So what I'm trying to do, I'm trying to pass the value of this s to the new str variable. Okay, and now I'm trying to print ln new str is new str and s is s. Okay, now let us compile and see what will happen. So Rust C dot slash practice dot rs. This is how we compile a single Rust file. Okay. So when I compile, you can see an error. Now this is what I would like to show you, that you can see this way. I think this is visible, right? The terminal is visible. Okay. Okay. Then you can see that let s equal to string. Here it says that move occurs because s has the type string, which does not implement the copy trait, and I have moved my value of s to new str. So what happens is, I have moved the value in s to new str, and then I am trying to access s in the third println statement. Now this is invalid in Rust because a type whose copy trait is not implemented, its value can be moved. But the problem is, once you move the value from an initial variable to a secondary variable, then you cannot access the initial variable. Okay, I think that is clear. So, but I want you to show something interesting again. So let's pay attention. Rather than the string whose copy trait is not implemented, what if we try with let x, which is I32, is 25 or like 35, and let y equal to x, and then I'm going to use my println function, that x is x and y is, yeah, so we don't want this. Okay, now let's compile. As you can see, there is no compilation error, I guess, so it takes some time to compile. Yeah, there is no compilation error. Now we can actually see the execution. Dot slash practice.exe and see that x is 35 and y is 35. So what happened? Now both x and y contain the value 35. But this is not the case with string, where the string passes its value to the successor when we do a move. Okay. I think that idea is clear. Now this is very important. So whenever you try programming with strings, keep this in your head that once you move a string from one variable to the other, you are not able to access it from the first. Okay. But what if we can still access it from the first? Okay. Now let's see that. So coming back to the old program, you see, I just tried to pass the S itself into the new str. Okay. Now what if I change this to s.clone? So what happens here is we take a clone or a copy of the S and we are passing the copy to the new str. Now this is where the idea of ownership comes into play. So previously we were trying to send the ownership of the hello world string from S to new str. But right now what we are trying to do is we're trying to take a clone of S and then we are sending this clone of S to new str so that the ownership of the hello world still remains with S. Okay, this is a bit hard to understand, but try to get it from the examples that is being shown right now. So the ownership of the hello world string remains with S even after passing it to new str because we took a clone of S. Okay, now these are stuff which are actually peculiar to only Rust. So try to understand. Okay, now let's compile again. So Rust now it compiles, So now it's yeah, string is hello world and new str is hello world and s is also hello world. Okay. So what happens? So new str and s both can be printed because we have only passed a clone of s to new str. Okay. Think the idea is clear. Now that was all for ownership. Okay. So the idea is to take a clone in order to pass it to a next string. Okay, now there is also one more thing that we need to discuss, that is to pass a string to a function. Now this is also one of the largest menace or bugs that you can see in case of Rust if you're trying to program with Rust in a long period of time using structs and all other different kinds of objects. See, once you pass a particular kind of object or a variable's content into a function, unless you don't return it back from the function, you cannot access it in the main function. Okay, some of you might have understood. Now I would show you an example. So I have created a string s, and I am going to pass it to a function called display string. This is my own function. Okay, display string s. So I have passed the variable to display string. This is a function that I'm going to define right now. So in order to define a function, we need to use fn, the name of the function. The spelling should be right. Okay. And we are passing s, which is a string. And we are not going to return anything. Just we are going to print ln the input string is s. Okay. Yeah. Now let us execute this. No, there won't be any kind of, okay, I'll show you the execution. So when I execute this program, there is no error. And as you can see, when I execute, you can see the output. It prints the input string is hello world. Okay. Now it's because it is executing the function call. Okay. So it's executing the function call. That is when you call the function here, it executes the function body. And that is why we are seeing the println, the input string is s. I think the idea is clear. Now, what we will do is we would try to println the string in main function is s. And the string in my function is s. Okay. Now let us try to compile the program. Okay, now you have an error. Why? So if you see the error closely, now one of the habits that we need to create while programming with Rust is to understand the error messages, because Rust compiler gives some of the most beautiful or informative kind of um, error messages that can be used to solve the problem, sometimes easily, sometimes it won't really help you at all. It would put you into much kind of like harder levels, but mostly it is really useful and it's really appreciable to read it and find what is happening with the program. So if you see, first we have created the variable and we have passed its ownership to S. So now the ownership of hello world is sustained within S. And now I'm passing this S to the display string function. Okay, now what happens is when I call S in the display string function, what happens is this S is being taken by this function. Now the current owner of the S is the function display string. Okay, the function display string. So the ownership of S in the main function has lost its content and it is being passed to the display string function. So now after passing that, you cannot access that S here. Okay. So once it's similar to the previous case where I showed you, like let S is this and new str, then once I pass the value new str, then I cannot access the value from S. Now rather than passing it to a new variable, I'm passing it to a function. So once I pass an S to a function, then I cannot access that value. That means you cannot access this value S after you have passed it to this function, because you are not returning the value back to here. Okay. Now the question is, how can you solve this problem again? So what if I just add an s dot clone? Okay, let's see what happens. Okay, now the program runs well. So yeah, it will be executed. Takes some time in my system. I don't know why. Yeah, now you can see two print statements would occur because of the first one being the function call and the second one being the println that is being written in the hello, that in the main function. Okay, I think you got an idea. Now, I have just used clone like literally in everyone. And the question that would be arising in your mind would be, then why are you implementing such a feature if you can use a clone to solve this problem? Well, the idea behind using clone is actually use of clone is not advised because it's an expensive process to do so. We have one of the easiest process in order to solve this same problem using references. So memory allocation with strings, we have discussed. In order to support a mutable global piece of text, we need to allocate an amount of memory on the heap unknown at compile time to hold the contents. I think this is clear with you because we need to store the string in heap as it might grow in the future. Now the memory must be requested from the memory allocator at runtime, and we need a way to return this memory allocator when we are done with the string, and that first part is done by so when we call string from this implementation, this is how it actually works. So when you use the string from, you are actually taking the memory, asking the memory, and then you will return it once you actually pass it to some kind of function. Now the basic idea is when you pass a particular variable into a function and the function call has been completed, then a drop function will be automatically called in order to throw away the particular variable. Okay. So the memory that has been occupied by the variable would now be destroyed or now be freed so that it can be used for another variable declaration. Okay. The idea is so simple. Just keep this in mind. So for those who are actually not familiar with memory management and other computer science fundamentals, it might be a bit hard to understand. But please try to go up with me, because in the programming side, it won't be much of an issue. But to understand, the concepts of the language, you might require to know what is memory allocation and all other stuff. Okay, like the different kinds of algorithms and best fit and all kind of, you might be knowing it, some of you might not be knowing it. It's not very important for us. Okay, now that is it. Once returned, the variable will go out of its scope, and there is a natural point at which we can return the memory our string needs to the allocator when s goes out of scope. And yeah, and this function that it calls for us when it goes out of scope is called as the drop function. Okay. It's very important for you to know what is the drop function. And yeah, so Rust calls drop automatically when a particular string goes out of the scope. So after the function has been called and its call has been completed, then any variable that is present inside the function which is not returned back to the main function will be dropped. So the first question is, what function is called by Rust whenever a variable goes out of scope? The options are free, drop, deallocate, delete. The second question is, out of the following, which is immutable by default? And str, string, vec, array. Okay, it's time to close the boards. I'm going to share the results with you. So the first question was, what function is called by Rust whenever a variable goes out of scope? The answer is drop. And the second question is, out of the following, which is immutable by default? I have already mentioned that a string is mutable, but an and str is immutable by default. Okay, try to understand this time. An and str is actually a pointer to a string, so it is immutable by default, but a string is actually a more powerful data structure. So it has got a lot of options for it to be like what to be changed and mutated, to add more or to append more or push something into the string, concatenate string, remove something from the string, etc., etc., is possible with the string data type. Okay. Yeah.